So dear students, in this question from Computer Science 2017, the characteristic polynomial is given to you. It is also given to you that this matrix has one eigenvalue as 2 and you have to determine the largest among the eigenvalues. You have to determine all the eigenvalues first, then you find out which one is the largest. Since 2 is an eigenvalue, 2 must satisfy the characteristic polynomial. So what you should get? You should find that it's 2 cube minus 4 into 2 square plus a into 2 plus 30 equal to 0. Or this simplification, let us simplify it. So 8 minus 16 plus twice a plus 30 equal to 0. Or you can find that twice a equal to negative 8 plus 30 is minus 22 on the right side. Therefore, you find your a to be minus 11. And since your a is minus 11, you find that the characteristic polynomial becomes lambda cube minus 4 lambda square minus 11 lambda plus 30. This characteristic polynomial has 3 zeros since it's of degree 3. And you know that 2 is an eigenvalue, therefore lambda minus 2 is one of the factors. What about the other factors? For that, one can apply the vanishing method, etc. Like, you can multiply it by lambda square so that you can have lambda cube minus 2 lambda square. So there is minus 4 lambda square, so again minus 2 lambda, so minus 2 lambda square plus 4 lambda, and what you can do, it is negative 11 plus 4, that means it should be minus 15, so that you can have minus 15 lambda plus 30. So the factors are lambda minus 2. And if you find out the factors for lambda square minus 2 lambda minus 15, you can find that lambda minus 5 into lambda plus 3. Okay. So what about the values of lambda? You can find that the lambda are 2, 5 and negative 3. Clearly, the eigenvalue with the largest magnitude is 5. So the final answer is 5 to this question. Thank you. Our next question, 17 series, is from the civil engineering stream. And in this case, you find that a 2 by 2 matrix is given to you and there are 4 choices. And most of these choices involve an eigenvalue 3. They ask you, what about the multiplicity of the eigenvalue, and also what about the number of linearly independent eigenvector corresponding to the eigenvalue 3. So you can find that what is multiplicity. The number of times an eigenvalue is repeated is called its algebraic multiplicity or simply the multiplicity. As for example, you find that in this question, what are the eigenvalues? Suppose that the two eigenvalues are lambda 1 and lambda 2. Evidently, lambda 1 plus lambda 2 is equal to sum of the eigenvalues equal to trace of the matrix. So what is the trace? It is the sum of eigenvalues equal to trace equal to sum of elements along the principal diagonal, that is 5 plus 1, which is 6. What about the product of eigenvalues? You know the product of eigenvalue equal to determinant value. So what is the determinant value of this matrix? 5 into 1 is 5. Negative of negative 4 is plus 4, so it's 9. So you find that the sum is 6 and the product is equal to 9. So evidently the two values of lambda are 3 and 3 only. That means you find that the eigenvalue 3 is repeated twice. So what is the algebraic multiplicity? The algebraic multiplicity, or simply the multiplicity of the eigenvalue 3, is equal to 2, the number of times you repeat it. That means the multiplicity is 2. The first part is over. What about the second part? Now we have to determine the number of linearly independent eigenvectors. For that, you should start with, remember, for eigenvector related question, you should start with ax equal to lambda x or a minus lambda I multiplied by x equal to now. Now what is A? The matrix capital A, which is 5, negative 1, 4, 1. This is your A. What is x? Since you find that the matrix is a 2 by 2 matrix, therefore x can have exactly 2 components, x1, x2. What is lambda? You know lambda is the eigenvalue and here the eigenvalue is 3. So you have the system like this. By matrix multiplication, you find that you can have two equations, 5x1 minus x2 equal to thrice x1 and 4x1 plus x2 equal to thrice x2. 4x1 plus x2 equal to thrice x2. It looks like that you have exactly two equations which is exactly equal to the order of the matrix. Therefore, you find that the order of the matrix is 2, or initially you have these two equations. However, you should now simplify them. You find that both these equations are basically equal to 5x1 on left and thrice x1 on right. So twice x1 on left minus x2 equal to 0 from the first equation. What about the second equation? You find that here you have 4x1 minus twice x2. So 4x1 minus twice x2 equal to 0 is the second equation. But you should note that the second equation is nothing but 2 times the first equation. So one can remove the second equation from the system, and so that he can have only one equation with him. The number of equations that you have after this simplification is r. So you have exactly one equation. So r equal to 1. Clearly, what about the number of linearly independent eigenvector corresponding to this eigenvalue 3? The number of linearly independent eigenvector corresponding to the eigenvalue 3 is n minus r. N is 2, r is 1, so it's 1 only. And this is the answer over there.